If you saw the Bruce Willis movie Armageddon, the next story may sound familiar, but this one's real. 7 years ago, NASA launched its OSIRIS-REx mission. The goal was to collect samples from a moving asteroid and bring them back to Earth.
Moving asteroid. Just pause for a moment. Imagine that, right? The spacecraft is now about to deliver its precious cargo after traveling for nearly 3.9 billion miles. But the return to the planet is not easy. NASA senior scientist Amy Simon joins us now from Goddard Space Flight Center in Greenbelt, Maryland. Amy, welcome. Thanks very much for being with us. So before you talk about the mission, could you first tell us what exactly an asteroid is and why would we want to study them?
Absolutely. So asteroids are small rocky bodies. They're essentially the leftover remnants from when the solar system formed. And because they are pristine examples of planetary building blocks, we want to study them because they're going to tell us a lot about how the Earth and all of the planets in our solar system were formed.
Amy, OSIRIS-REx is really a complicated mission. As we mentioned, the asteroid is moving. It is out in space. We are chasing it, trying to puncture a little sample hole and then bring it back to Earth. Given that we've had asteroids crash into the Earth, we have samples from that. Why is it so important to undertake this complicated mission?
Really, the reason that we need to do a sample return versus relying on meteorites that have landed on the Earth is that contamination factor. We really want this pristine example of material that has not been sitting on the Earth's surface or burned up in the atmosphere. So it's really to get that very pure sample that we can study in our laboratories here.
And give us a sense of, without going maybe too in the weeds, but I remember covering this actually when OSIRIS-REx back then, several years ago, was first sort of underway, and the tremendous calculations, right, Amy, that had to take place in order to get the trajectory just right to get at that target. So the return is going to, as I understand it, be equally, perhaps, as complicated. Tell us what the challenges are with getting this back here to Earth.
Sure. So, even getting out there, as you say, was a challenge. It took us about 2 years for the spacecraft to catch up to Bennu in the first place. And then once we were in orbit, we spent about 2 years mapping out the surface to very carefully pick that safe location to take our sample from. And then another couple of years to get back to Earth, because again, the timing has to be just right to get into the right spot in the orbit. And what we'll see on Sunday is that the spacecraft is going to release that sample return capsule. It's going to enter the Earth's atmosphere, and we're going to be using parachutes to slow it down. So it'll land on the desert floor in the Utah Test and Training Range. And then our recovery team will spring into action to go pick it up and to put it into a temporary facility.
How fast will it be traveling, Amy? Just so I have a sense. I should mention.
We want all the details, Amy.
I asked because I was just on a plane back here, actually, to New York, and I was watching as the plane map was telling us how fast we were going. And now thinking about what your mission is, to think about traveling 3.9 billion miles to get back from Bennu is remarkable.
Yeah, and it is traveling fast. The way to think about it is from that Earth entry point when it's just at the top of the atmosphere, which is way higher than an airplane. That'll happen at about 10:42 Eastern time. It'll be on the ground at 10:55. So it comes in pretty fast.
Well, let's talk a little bit more about the possibility, because this is why space exploration study is so important. OSIRIS-REx didn't just grab these samples, but it also studied the asteroid in unprecedented detail. I'm wondering if you can tell us if anything surprised you about the study, and what would surprise you the most when the samples return to you? Is there anything that you're hoping to learn?
Sure. So we did spend that 2 years mapping it out in detail down to the tiniest pebbles because we really did want a nice place where we could get to that sample. And the big surprise we found was that there were no nice, clear depressions full of loose material. The whole surface was covered with boulders. So that was a challenge in and of itself to try to find that sample that we could safely pick up. But really, the purpose of doing this is because our laboratories have far more sophisticated equipment than we could ever fly with us. And so we really want to get those samples in the lab and be able to look at the composition, look at those rocks under microscopes. And, what are we hoping to see? Well, we're hoping that we'll see organics, we'll see amino acids, the building blocks of life, as well as evidence for past water on Bennu, because all of these things are the sorts of materials that asteroids and comets delivered to the Earth when it was forming and helped life to be able to flourish.
And from here, OSIRIS-REx becomes OSIRIS-APEX, right, Amy?
Yes, it does.
All right. Well,
so
go for it.
Once we release our sample, we will divert the spacecraft, and it will head on to its next target, which is near-Earth asteroid Apophis.
All right. We'll check in with you on that, as well as any interesting organics that you find when you look at the sample. Amy Simon, thank you.
Thank you.